Well, students, now we come to the vector addition. As you can see, it is written there, parallelogram law. So now in the parallelogram law, we have to add two co-initial vectors. So when I'm adding two co-initial vectors, you see I'm getting a line like this, and I'm getting another line like this, and say I'm adding these two. So what I am doing when I'm adding them is, according to the law, I form a parallelogram with the help of these two vectors like this. This is the parallelogram, and the diagonal of the parallelograms gives us the resultant. So according to the parallelogram law, if I have two vectors P and Q, and if I'm asked to find their resultant, well, P and Q are what kind of vector? Co-initial vectors. And then what I should do is I should draw a parallelogram, and the diagonal of that parallelogram is what is the resultant. Now how I calculate the magnitude here is what we are going to show you now. Say the vectors P and Q are at an angle of inclination theta. So the angle between P and Q is theta. Now from here I drop a perpendicular and I join these two lines, and this is a perpendicular. You see, this is because this arm is Q, this arm is also Q. As because this is theta, so what we have here is this perpendicular is Q sine theta, and this base is Q cos theta. So this is what we have for now, that this side is Q, this side of the parallelogram is Q, so this side of the parallelogram will also be Q. The angle between these two vectors is theta, and here also the angle between the vectors is theta. So if this is Q and this is theta and this is a right angle, then the perpendicular is Q sine theta and the base is Q cos theta. Now what we do is we apply the Pythagoras theorem or the Pythagoras rule here, that is the square of the base plus the square of the perpendicular is equal to the square of the hypotenuse. So now let us come to that how I can add these layers here. So now let me come to the situation that how I come to the layer. Now, so I'll just draw it here. This is a parallelogram that we are drawing, and this was the resultant, and this was the perpendicular. So this was your P, this was your Q, this was your Q again, and this was Q sine theta, and this was Q cos theta. So now what we are doing is, basically, we are having an angle of theta here, so the same angle theta is here also, and this is our resultant R. So when applying the Pythagoras, what we have is we write R squared, that is P plus Q cos theta whole square. So that makes it P plus Q cos theta whole square. And then I add with this perpendicular, which is Q sine theta whole square. So now if I add all these things together, what I have is that R square is equal to P square plus 2PQ cos theta plus Q square. So this is what we have for the final value of the parallelogram law. Now before getting on to the end of this parallelogram law, what we need to check out for once again is the fact that what happens when these two arms get alternative. You see, if these two arms get alternated, this is P, this is Q, then nothing happens here. Nothing happens here. So R is again P square plus Q square plus 2PQ cos theta. But what is very important is how you find the resultant of this direction in this case. So the direction of the resultant here, which is given by tan alpha, should be perpendicular by base. So if this is the figure, this is P, this is theta, this is P sine theta, and this is P cos theta. So you see, as you can see, the perpendicular is P sine theta, and the base, as you can see from here, is Q plus P cos theta. Q plus P cos theta. Now, in our previous case, let us check that case. For our previous case, what it comes on the previous case. The previous case where we have this as P and this as Q and this as the resultant R. In that case, what we were doing is this is P, this is Q, this perpendicular was Q sine theta, and this was Q cos theta. So in that case, what we were doing for this alpha, tan alpha, is that tan alpha is perpendicular. Perpendicular means Q sine theta here. And then it is by base, so it is P plus Q cos theta. So you see, this is how we have to get the resultant changing if we have the values of P and Q interchange. So students, be very careful about this. When you change P and Q, the resultant do not change, but indeed this angle, the direction changes. So that should be taken into account. That's for all now. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.